Welcome viewers. Today we are at lecture 2, the second part of the introduction to smart grid. As we discussed during last lecture, the background definition of smart grid at large and also the major components of smart grid. And today we will get into in detail different definitions of components of smart grid and different IEEE standards and communication networks, protection mechanism, and hope today's lecture will be very useful if you have understood in detail of your first lecture. Now, first of all, when we talk about power generation, present electricity is generated at few central power plants by electromechanical generators primarily driven by the force of flowing water or heat engines fueled by chemical combustion or nuclear power. Now, perhaps we are just interested to see that in future how my power generation is going to change or take new shapes. Now, the smarter power generation becomes possible as the two-way flow of electricity and informations are supported. Means currently it is mainly as per the demand driven, but if you can do both side communication, the generation is based on the expected demand and the demand can drive the generation as it desires. Now, the very important component of the smart grid power generation such as distributed generation which can certainly play a key and major role in our smart grid. Now, there are different types of distributed generations. Let us discuss based on their energy based technology type, primary energy, output type, advantage and disadvantage. So, this will give us an idea different type of distributed generators as well as how they can be integrated in my smart grid and what kind of merits that we can achieve and the limitations that you have to face. For example, the first one is reciprocating engines, diesel or gas as my primary energy, and the output will be of AC type. And you can see that the major merits of this reciprocating engine is low cost and it is high efficiency, ability to use various inputs, but the main disadvantage is environmentally unfriendly because of emissions. Now, the gas turbine which is again diesel or gas as my primary energy source and the output type is AC, but the major merits are high efficiency using CHP concept, environmentally friendly, cost effective, but it is quite large for consumers. Now, then move to micro turbine concept which is either biogas or propane, the output is again AC type. Advantages are small size and lightweight, easy startup and shutdown, low maintenance cost, and the disadvantage is because it is quite expensive technology, cost effectiveness to the price of the fuel is not appropriate and environmentally unfriendly. Then moving to fuel cell, ethanol H2N2, the output is DC. The major advantage that we could see is one of the most environmental friendly generator as well as extremely quiet, no noise, useful for CHP and electricity applications. But the major disadvantage is extracting hydrogen is quite expensive, expensive infrastructure for hydrogen is required. Now, the very commonly used distributed generation in today's world is wind. The primary input is naturally, which is wind, and the output type is AC. The merits are day and night power generation, one of the most developed renewable energy technology. Disadvantage, it's quite expensive, and we need to have a storage mechanism, and it may have effect, since a serious effect, especially due to the climate disasters. Now, next is geothermal. Hot water is my primary energy source, the output is AC. The merits are extremely environmentally friendly, low running cost, whereas the disadvantages are environmental impact, non-availability of geothermal spots in the land of interest. Now, the next one, once again one of the most important distributed generation energy source in current scenario, which is photovoltaic systems. The primary energy source is our sun, the output type is DC. The major advantage is emission free as well as useful in a variety of applications, but the disadvantage is high upfront cost, though it is keep on reducing over a period of time, but still it is expensive. Storage mechanism is required, as well as one of the very important requirement, we need to have lot of land for their installations. Now, the biomass gasification, the primary energy source is biomass, the output type is AC. The advantages are minimal environmental impact, available throughout the world, alcohols and other fuels produced by biomass are efficient. The disadvantage is it is expensive and net loss of energy in a small scale. Now, the solar thermal, the next one is let us concentrate on solar thermal, sun and water. The output type is AC, simple, low maintenance, operating cost nearly 0, mature technology, and the disadvantages are unknown operations and maintenance cost, low energy density and limited scalability. Now, the next one is a small hydropower. The primary energy is water, the output is AC. The very major advantage that you could see is economic and environmentally friendly, relatively low upfront investment cost and maintenance, useful for providing peak power and spinning. But the disadvantages are suitable site characteristic required, difficult energy expansion, and in case of ocean energy, though it is not very common, but is upcoming technology where the input primary energy will be of the ocean waves and the output will be of AC type. High power density is one of the major merit, more predictable than solar and wind, but unfortunately it has unknown operation and maintenance cost and majorly lack of commercial projects. Now, similar to power generation, we have seen for conventional generation and in specific smart power generation in the form of distributed generation. Now, let us concentrate how my transmission network look like and what are the components within transmission system. Now, the transmission defines as based on the increasing load demands, quickly aging components, power carrying limitations and cost of installing new transmission lines given a new berth to advancement of transmission system. Innovative technologies such as new material, advanced power electronics and communication technologies drive the development of smart transmission grid. Now, according to us, smart transmission grid can be regarded as an integrated system that functionally consists of three interactive components, and let us see what are those three components makes my transmission system smarter. Smart control centers, smart power transmission networks, and finally smart substations. So, upgradation of the existing transmission system by installing or establishing smart control centers, smart power transmission networks as well as smart substation can make my transmission system reasonably smart. Similarly, now let us understand what is distribution system and how we can achieve a smart distribution system. Deployment of grid connected distributed generators at distribution level increased significantly. Increase in deployment makes the power flow control much more complicated, in turn necessitating the investigation of smarter power distribution and delivery mechanism. Now, distributed generation promotes the development of a new grid paradigm called microgrid, which is seen as one of the cornerstones of the future smart grid. Within distribution, now we like to create a smarter distribution system at different voltage level, so called smart grid, considered to be the major important cornerstone of the future grid. So, dear listeners, I wish to emphasize at this point of time the major challenge on smart grid against the conventional grid would be focused at each and every level, starting from generation, transmission and distribution, but the major focus will be at distribution level, because the distribution level need to be made absolutely smarter for achieving reliable economic energy for the customers. To achieve that, we need to have smart information. Now, what is smart information? The evolution of smart grid relies on not only the advancement of power equipment technology, but also the improvement of sophisticated computer monitoring, analysis, optimization and control from exclusively central utility locations to the distribution and transmission grid. Now, many of the concerns of distributed automation should be addressed from an information technology perspective, such as interoperability of data exchanges and integration with existing and future devices, systems and their applications. Smart information subsystem is used to support information generation, modeling, integration, analysis and optimization in the context of the smart grid. Now, if you look at smart information system example, now first of all this is the utility, and we do have energy storage devices in place, and then we have the smart meters, and then the smart routers are placed, and the smart meter home area network is through low cost Zigbee metering communication devices are placed for the exchange of information within smart grid. Now, one of the major concern that a distribution system can be made smarter only if the data at different nodes will be made available in distance through a Wi-Fi mechanism, and for that we need to have smart meters in place. Smart meter is usually an electrical meter itself that records consumption in intervals of an hour or less, even at 5 minutes interval, 15 minutes interval, half hourly interval as per the requirement, and that information at least daily back to the utility. The information is being recorded and then transmitted to the utility for monitoring and billing process. Automatic meter reading, very commonly known as AMR system, is the technology of automatically collecting diagnostic, consumption and status data from energy meters and transferring that data to a central database for billing, troubleshooting and analyzing. So, smart meter do play an important role in sending all the information of the grid to the utility, so that different troubleshooting analysis can be performed for a given time. Automatic meter infrastructure, that is so called AMI, differs from traditional AMR in that it enables two-way communication with the meters. Therefore, nearly all of this information is available in real time. So, AMR is certainly a helping instrument for smart grid infrastructure, but the smart grid infrastructure or the automatic meter infrastructure AMI do have two-way communication. Therefore, nearly all this information is available to the utility in real time. Now, let us move to the second important component of my smart grid, that is sensors. Sensor networks used as a monitoring and measuring unit for a grid. Need of sensor in the smart grid is mainly because of its quality of service, resource constraints, remote maintenance and configurations, high security requirements, harsh environmental conditions. Now, one more important point here I like to emphasize, that we need to have phasor measurement units, that is PMUs. PMU mainly measures the electrical waves of an electrical grid to determine the health of the system. The major functions of PMUs is mainly provide loss of main protection, monitoring fault events, locating disturbances, estimating grid state, studying synchronous islanded operation, monitoring power quality, devising experimental setup or applications for the monitoring of active distribution grids. Now, and hence we have to manage the information. The information management is being carried out through different steps. Large amount of data and information will be generated from metering, sensing and monitoring through different equipment and devices, and those will be passed to smart grid that needs advanced information management technique, which handles data modeling, information analysis and integration and optimization. So, all the data, they are being transmitted to the second level, and further we can say that the information analysis is needed to support the processing, interpretations and correlation of the flood of new grid observations. And finally, information integration aims at the merging of information from disparate sources with different conceptual contextual and typographical representations. Now, let us move to smart communication. It deals with the connectivity and information transmission among systems, devices and applications. Reliable and effective information exchange is a key to the success of the future smart grid. Basic functional requirements. Now, we need to have quality of service of data, critical data. Example, grid status information must be delivered promptly. It has to have high reliability. Guaranteeing the reliability of such a large and heterogeneous network is not a trivial task. High availability and coverage. This is mandated by the principle that the smart grid can respond to any event in the grid in time. It must guarantee security and privacy. Smart communication, we can see one of the major smart communication is wireless communication. It has wireless, mesh network, cellular communications, cognitive radio, and all this wireless communication is quite important for successful operation of a smart grid. Now, when we talk about wired communication, they could be either fiber optic communications or it could be power line communications. So, these two type of communications are being commonly used, and in case of wireless communication, that offers significant benefit over wire technology, such as low installation cost, rapid deployment, mobility etc. can be achieved, but are also more suitable for remote applications. Now, let us say that wireless communication is certainly an important infrastructure, but wireless communication has already been widely used in our daily life and can be deployed anywhere, anytime. So, this is not a new technology, but we should take advantage of this existing wireless technology and incorporate within our energy grid to make it smarter. Wireless mesh network. It is a communication network made up of radio nodes organized in a mesh topology, has emerged as a key technology for next generation wireless networking. Now, what do you understand by cellular communication system? It is a radio network distributed over land areas called cells, each served by at least one fixed location, transceivers known as cell site or base station. It has proven mature technology for data transmission for several decades. Now, let us discuss cognitive radio. This has been proposed for smart grid based on IEEE 802.22 standard. It is used as secondary radio to handle high volumes of non-critical data and also act as backup radios in emerging or emergency situations. Wired communication, certainly it is fiber optic communication. It has been used by large power companies to connect their generation network with their network control facilities. Furthermore, its electromagnetic and radio interface immunity make fiber optic communication ideal for high voltage operating environment. It has high bandwidth capacity and immunity characteristics, although It is well known that the installment cost of optical fibers may be expensive. Fiber optic network is still a cost effective communication infrastructure for high speed communication network, which is the backbone of the future smart grid. I mean you must have listened to my past lectures. All the time it has been told that your existing grid will be made smarter by communication establishment through two-way transformation, information transformation in any form. So, that means the information can be exchanged only through a better communication media, and we understand that the fiber optic communication can certainly be an asset for the future smart grid technology. Now, we perhaps along with fiber optics we do use power line communications, which is a very old technology. Power line communication, that is PLC, is a technology for carrying data on a conductor, also used for electric power transmission. In the last decade, utility companies around the world have been using PLC for remote metering and load control applications. Technically, in PLC, power electronics are used to manipulate high voltage waveforms for signal and information oriented applications. So, even though it is being a wired communication technology, but first narrowband PLC is well suited for smart metering infrastructure, very important. Dear listeners, smart metering infrastructure is well suited for the wired communication based on PLC, and certainly we look forward to a huge PLC infrastructure for our future smart grids. One more important point, the second one, is PLC enables the communications between electric vehicles and power grid via power line without introducing other wired or wireless equipments. Third, broadband PLC can provide the service of transferring data seamlessly from smart grid controller to home networks and vice versa. Now, the smart communication in a smart grid, let us see, this is the utility company and the consumers through wide area networks. It could be BPL, could be fiber optic, could be wireless network, and then we do have the field area networks for my smart meters, and the smart meters can be installed in my power lines. This is my distribution lines, and the whole utility can connect to my home, shop and factory through smart meter data using field area networks as well as wide area networks. So, that means the communication between the users and the source can use communication as a platform for their interaction to make the grid smarter. Smart management is mainly to increase the efficiency of energy, operation cost reduction, demand and supply balance, emission control, utility maximization, and one more component is our smart protection to achieve system reliability, failure protection mechanism, mainly to failure prediction and prevention, failure identification, diagnosis and recovery, microgrid protection, security and privacy. Security and privacy is also equally important in smart infrastructures, information metering and measurement, privacy in smart metering, security in monitoring and measurement. Smart protection system achieve system reliability, that is ability of a component or system to perform required functions under stated conditions for a stated period of time. Local power generation can reduce the likelihood of cascading failures. An ideal mix of the smart grid resources like renewable, demand response and storage lead to flatter net demand and eventually increase system reliability. Failure protection mechanism, that is prediction and prevention, predicting the weak points of the region of stability existent in its energy subsystem. Some researchers proposed to utilize PMU data to compute the region of stability existence and operational margins. Major blackouts can be prevented by proper predictions. Failure protection mechanism, locating and identifying the failure to avoid cascading events. Due to the wide deployment of PMUs, the phasor information used for line outage detection and network parameter error identification. Self-healing can be effective if power grid is divided into small sections. During post fault, decision making abilities should be distributed to the substation and or field device for immediate action. Then we have different schemes of protection. We have microgrid protection, that is protection of microgrid, especially when it is islanded, is quite challenging. The first and foremost challenge is to detect the islanding of the microgrid. The second important challenge is how to provide segments of the microgrid with sufficient coordinated fault protection while operating as an island separated from the utility, which is one of the very important during fault condition, how we can operate the grid in an islanded mode. Cyber security is regarded as one of the biggest challenge in smart grid. Vulnerability may allow an attacker to penetrate a system, obtain user privacy, gain access to control software and later load conditions to destabilize the grid in unpredictable way. The smart grid, though it seems to be the future, we have to incorporate robust cyber security mechanism to make your grid safer. Smart meters are extremely attractive targets for malicious hackers, since vulnerability can easily be monetized. Wide deployment of monitoring and measurement devices could also lead to system vulnerability. The major challenges in smart protection system is especially in specific interoperability between cryptographic systems, conflict between privacy, preservation and information accessibility, impact of increased system complexity and expanded communication paths, impact of increasing energy consumption and asset utilization, complicated decision making process. And with this background, now researchers establish few standards to establish your smart grid infrastructure. And let us now discuss some of the very important IEEE standards. We do have the first one, which is very important, that is IEEE 1547 interconnection standards. IEEE 1547 in 2003 takes care of interconnecting distributed sources with electric power system. What are the standards that need to be maintained for interconnecting distributed energy resources with any existing power systems. Next one is IEEE standard 1547 version 1 in 2005. It deals with equipment interconnecting distributed resources with electric power system. Then we move to the second version 1547 IEEE standard in 2008 that talks about application guide for IEEE standard 1547, IEEE standard for interconnecting distributed resources with electric power systems. The third version in 2007 monitoring, information exchange and control of distributed resources interconnected with electric power system. Then we had fourth version in 2011, design, operation and integration of distributed resources island systems with electric power system. IEEE P 2030 interoperability standards, IEEE P 2030 guide for smart grid interoperability of energy technology and information technology, operation with electric power system and end use applications and loads. IEEE P 2030 version 1 guide for the electric sourced transportation infrastructure. IEEE P 2032 guide for the interoperability of energy storage integrated with electric power infrastructure. But though the IEEE standard suggests recommendations for smart grid development with different standards, there are few barriers for smart grid technologies too. One of the major barrier, a huge amount of investment and lack of financial resources, because we need to really invest too much to make your grid smarter. Market uncertainty, we do not know how the market is moving. Lack of regulatory frameworks, none of the very strong established framework is in place today. Low public awareness and engagement, for example, the day to day public life, they are not mature enough to understand, are they operating at the peak hour or the off peak hour, how they can contribute to green energy, how they can reduce the energy demand during peak hours. So, for all these concerns, we need to have extremely awareness programs, first of all to educate all the public, those use energy in a regular basis. Lack of innovativeness in the industry, industry has to be more innovative. Lack of infrastructure, technology immaturity, integration of the grid with large scale renewable generation. That is the biggest challenge when we put lot of renewable energy sources in the existing system, which has not been designed to incorporate excess renewable energy. We have to have grid challenges. Need of advanced bidirectional communication system, cyber security and data privacy, very, very important. Dear listeners, we end with our introduction lecture 2. And when we meet next class, we will get into details of smart grid modeling and technical aspects of smart grid. Thank you.